We have finally reached the final section for geometry this year. It is 12.5 combinations and permutations. So you are going to need a graphing calculator for this or to find an equivalent website that can do everything you need to do on your calculator. So combination permutation is different. A combination is a selection chosen from a group where order does not matter. Maybe it's a handful of M&Ms you're taking from a bowl. It doesn't matter which ones you're grabbing in what order, you're just grabbing a handful. Versus a permutation, which is a selection chosen from a group where order does matter. Perhaps it's the SAC elections and whether or not you're chosen as the vice president or the president does matter. So we're going to talk about combinations versus permutations. So I want to pick 3 letters from A, B, C, and D. So we'll come up with all of the combinations versus the permutations. So here the combinations, they don't matter. So I could do it without D, A, B, and C. I could do it without C, without B, or without A. So there are 4 combinations. When choosing 3 from 4. Choosing 3 things from 4 things. However, once we do permutations, that order does matter. So let's start with A, B, C, D. Sorry, just A, B, C. What are all the ways that we can do a different order of that? Well, A is first. There's another way A is first. B is first. Or C is first. All right, we have A, B, D. So all the ways we could order that so that order does matter. A, D, B. B could be first. Or D could be first. The next one was A, C, D. And if order matters, like in a permutation, all the different ways we can do that. So A, C, D, A, D, C, C, A, D, C, D, A, D, A, C, D, C, A, or the last one is B, C, D. So all the orders where we can do B, C, D, do C first, or it could be D first. So those are all the ways to, this is an A, those are all the ways to choose 3 letters from these 4 when order matters. So whereas there were just 4 combinations, there are 24 permutations because you have more options once order matters. Now, listing out all the possibilities is not a reliable way to do this. So there are formulas for combinations and permutations. So, are objects from a group of n objects. So n is the total is the group total. Sorry, no, just N is the total, and R is the chosen group. The formula for this, so it's a combination. We do a big C. Now, that is an exclamation point. In math, that's called a factorial, and I will show you what that means in a moment. So to find the combination, when N is your total and R is how many you're picking, it's N factorial over N minus R factorial over R factorial. It's a lot of things. So what is a factorial? Well, let's say, as an example, I have 5 factorial. A factorial is equal to 5 times 4 times 3 times 2 times 1. Whenever something is a factorial, you're multiplying it all the way back. All right. For a permutation, again, so N is the total, R is the chosen group. A permutation formula is N factorial over N minus R factorial. Now you'll notice the only thing that's different is with a combination, you're also dividing by more. So when you divide by more, because there's more on the denominator with this R factorial, your number is going to be smaller. That's why the combination is always less. Now, what if I am choosing everything from a group? So if N and R were equal, so if N and R are equal, there's 5 people and I'm choosing 5 people. I'm just kind of looking at the order. In which case, N minus R would give us 0 factorial. 0 factorial is equal to 1. So if you ever have a 0 factorial, they'll equal to 1. So how do you find this on your calculator? Well, you can do any number you want. Go to the math. Probability, that's what this whole chapter is about. And you can enter the exclamation point. So 5 times 4 times 3 times 2 times 1 is equal to 120. So let's do a couple examples of that. So you order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations is possible? Now it's combinations because order does not matter. Does it matter if you get the coleslaw and the fries or the fries and the coleslaw? No. So I'm choosing 2 sides from a possible list of 8. So all the combinations is N factorial over N minus R factorial times R factorial. So that gives us 8 factorial over 8 minus 2 factorial times 2 factorial. So if we were to break those down, we would get 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, well, 8 minus 2 is 6, so 6 times 5 times 4 times 3 times 2 times 1 times 2 times 1, because that's, so then you have those 2 separate pieces. But you could do all that math out, or you could cross things out. So 6 and 6, 5 and 5, 4 and 4, 3 and 3, 2 and 2, 1 and 1. So what am I left with? I'm left with 8 times 7 over 2 times 1. That's 56 over 2, 28. So there's 28 combinations. When choosing 2 from 8. Now let's try a permutations. So a class of 10 has a mock election. They elect a president, vice president, and representative. How many permutations? It's permutations now because order does matter. Whether someone is chosen as the president or the representative does affect it. So permutations, that's n factorial over n minus r factorial. So I have 10 total. I'm choosing 3, president, vice president, representative. So 10 factorial over 10 minus 3 factorial. Now keep in mind, 10 factorial is 10 times 9 times 8 times 7 times 6, so all the way back. You could also do that as 10 times 9 times 8 times 7 factorial, because 7 factorial would be the rest of them. In which case, you don't have to write them all out because these just cancel. So you get 10 times 9 times 8, which is 720. So there's 720 permutations here. So you're going to have to use your calculator, or if you're using an online calculator, make sure that when you use an exclamation point, it's registering it correctly. You can always test it by doing 5 factorial. You should get 120. And please now go and watch 12.5 part 2, which is the final video for this year.